Good morning, Year 11 Science students. Today we're going to make a start on acceleration, and with it comes a new formula, which is acceleration is equal to change in velocity over change in time. So again, we're using the Greek delta triangle symbol to indicate change. This could be expanded to be Vf minus Vi, okay, which is the final velocity take away the initial velocity, which is a way of working out change in velocity over change in time. So, for example, if a car was going at 50 meters per second and then it sped up to 70 meters per second, to find the change in velocity, you would go 70, take away 50, and you can see that its change in velocity is 20. So that one there would be Vf, and that one would be Vi. So Vf take away Vi is equal to that change in velocity of 20 for that particular scenario. So we could use Vf minus Vi, which we'll use at some point. Alright, if we want to put this into our rearranging triangle, then we need to put the change in velocity goes up the top, and acceleration goes there, and time goes there. So if you ever wanted to find out the change in velocity, then you'd be acceleration times time. If you want to find out time, then you change in velocity over acceleration. And if you want to find out acceleration, it's change in velocity over time. Okay, well, one other thing I'll point out is the units for acceleration. So change in velocity. Velocity has the unit of ms minus 1, and time has the unit of s. So it's s minus 1 divided by another s, and that simplifies to be ms minus 2. So that's going to be the unit for acceleration. Right, unit there. Alright, on to my first question. A bike's travelling at 6 meters per second and it speeds up to 10 meters per second. This takes 7 seconds. What is its acceleration? So we'll write that down. Acceleration is equal to change in velocity over change in time, and we'll write down its final velocity was 10, take away 6, which is its initial velocity, and we divide it by the time it took, which is 7. So that gets changed to 10 take away 6, which is 4, divided by 7, which equals 0.57, and we need to put a unit on there, which is ms minus 2. Alright, on to our next question. A rat slows down from 14 meters per second to 2 meters per second when it sees a trapper. This takes it 20 seconds. What is its acceleration? So we'll write down our formula, like we always do in physics. Change in velocity over change in time. And we need to write down final velocity is 2. Take away initial velocity, which is 14. So 2 take away 14, divided by the time it took, which is 20. Put that in brackets. 2 take away 14 gives us negative 12, divided by 20. This gives us negative 0.6, and that is ms minus 1. And notice the negative sign. That's because it's slowing down. So for this question here, it was speeding up, so you get a positive answer. For this one here, the rat was slowing down, so you get a negative answer. All right, now we're going to move on to a graph. It's a similar system to what we did with distance time graphs, but you've got to remember that this is speed time. So for the first section here, section A, you can see the speed was 0 there, and then it increases to 2. That means it's acceleration. So for A, it is going to be accelerating. For B, its speed is 2. And then at the end of the section, it's still 2. So that means it's constant velocity. Okay, don't get confused. Remember, a horizontal line on a distance time graph was stationary, but a horizontal line on a speed time graph is constant velocity. Now we get to this one. Starts at 2 for section C, ends at 6. So its velocity or speed is increased by 4. That means it's accelerating. Here is another example of constant speed. For this bit here, it starts at 6 but ends way down at 1. That's deceleration for section E. we'll just run one calculation for fun, and it's going to be section C. So we'll put it there, section C. So we've got acceleration is equal to change in velocity over change in time. And we'll write down the change in velocity was 6 minus, because it reads across to 6, minus 2. Minus 2. And the time it took was from 3 to 4 seconds. So therefore the time it took is going to be, we'll write it down, 4 minus 3. Put them in brackets. I'll come down here to carry it on. Acceleration is therefore 6 minus 2, which is 4, divided by 4 minus 3, which is 1. And we got to go 4 divided by 1, which is 4 ms minus 2. And that's its acceleration. So that's why it's such a steep line there, because it's accelerating at a high rate. Thank you for listening.